Molweni, hello, igama lam nguDamsoso. Ndithanda maths. And I'm cooking in the background, so if you start hearing boiling sounds, yeah, it's not in your head. It's happening. We're making some rice. So, multitasking in action. It's been a minute. Honestly, I did record 2 videos a day or 2 ago, but then the second video went so badly, like I messed that question up so much, and I was already having such a miserable day, so then spirit levels just went below planet Earth. So hoping to reset that glum. I mean, it's been reset to a large extent, but now I need to reset it specifically in the realm of continue to make content. Which should be fine, I think, from here. If this doesn't go badly, then I should be able to do, like, I'd really like to power through and just like finish the rest of the questions that I've picked for this paper. That paper being, this paper being, that paper being, this paper being the department's November 2023 paper 2. I'd really love to finish the 2023 series. So let's hope I can power through it tonight with some rice cooking in the background. Okay, right. So question 5.4. Simplify. They give us this bombastic looking fraction to a single trigonometric ratio. Okay, so I won't lie, like as I was preparing the slide, by preparing the slide I literally mean just copying the image over onto the document anyway. But just from like quick glance, my immediate thought was, okay, we have a sine 3x, we have a sine x, we have a cos 2x. So we are talking about potentially 3 different angles here, right? And if we want to simplify to a single trigonometric ratio, then I presume we're going to need that ratio to be, well, yeah, I'm not presuming, I am correct that it's going to have to be a ratio of 1 angle. And so what feels like the natural choice to me is to choose to make x the destination angle. So we want to end up with a cos x or a tan x or a minus sine x, something like that, right? And the reason why I'm choosing x as our destination angle, in fact, we could even choose 2x as a destination angle, honestly, but anyway, let me stick with x, is because 3x, for example, is equal to 2x plus x, right? And we know some special identities that have to do with double angles, 2x, and compound angles, so the 2x plus x would be catered for. And then of course something like cos of 2x, we can also use the double angle identity to rewrite as some expression that has to do with the ratios of x. So that's why it feels like, yeah, x is a good choice for us to kind of not break them down, but like, rewrite each ratio so that eventually it's talking about x instead of talking about 3x, or talking about x instead of talking about 2x. So let's see. I'm gonna endeavor to write sine 3x eventually as something that is just about x. So I'm going to use the compound angle identity. So I'm first gonna rewrite the 3x as 2x plus x, so that I have the 2x and the x. Then we know that using barring the compound angle identity, this is the same as sine 2x cos x plus cos 2x sine x. Okay, and because there's a cos 2x at the bottom, I'm just going to leave it at this for now. But for example, I could take it further and rewrite this as 2 sine x cos x, right? So as in replace this with this, so that now this term is only dealing with the ratios of x. And then similarly, I could figure out a way to rewrite the cos 2x so that it's about x instead of 2x, but let's see if we need it or we don't need it, or kanjan. For now I'll just leave it at this, right? So now actually I'm thinking this might be a bad idea, because now we have sine 3x is equal to this, plus the sine x up here. None of these are like terms, so we can't even add them. So there's no future really. Whereas if I do in fact go ahead and rewrite this as 2 sine x cos x, then there's going to be a common factor of sine x here, and sine x here, and maybe then we'll start getting a bit of direction. So I am indeed going to go right ahead and replace this with 2 sine x cos x. Okay, and then the other cos x is just hanging on for dear life there. This one I will leave. How does it just become an eraser J of its own volition? I mean, it's not of its own volition, it's probably me pressing it by mistake, but still. Right. So let's just write this a bit more nicely. So this is 2 sine x cos squared x plus cos 2x sine x. Hey, the rice is starting to boil, guys, so there might just be a weird absence shortly. Okay, right, so now we can rewrite sine 3x plus sine x, i.e. this guy over here, as something I am not going to rewrite. Okay, so that plus sine x. Okay, and then as planned, we can factor out the common sine x. So now we're left with 2 cos squared x plus cos 2x plus 1. So now, interesting things, because hey, there's a cos 2x plus 1 and a cos 2x plus 1 there, but of course we can't do any cancelling, because why would you do that? So if you treat this as one term, you know, if you put brackets or if you factor out a 1, you can't just now randomly come and cancel it with a part of the factors of the top, like like this cos 2x is hidden inside a factor. You can't just now come and randomly cancel. Anyway, but I do wonder if it is worthwhile to rewrite this. The rice, guys, the rice. So I'm tempted to use, I don't know how it goes actually. Is it like this? I think it is like that, yes. Because that way we are just going to have 4 cos squared x, and then the minus 1 plus 1 are gonna cancel out. That's not what I thought would happen. Oh, but then if we replace the bottom one as well by this, then the minus 1 and the plus 1 are also gonna cancel, and then cancel. I wish you could see what I was doing. On second thoughts, I'm glad you can't. So let us go right ahead with that plan, because cancellations are a vibe, yo. Okay, so let's highlight what happened here. So we replaced the cos 2x with that. Okay, so then we have 4 cos squared x. Minus 1 plus 1 is just 0. So now for the whole fraction, okay, no, not yet. Let's not get too excited. Let's go to the denominator. So the denominator is just cos 2x plus 1. And we've seen a similar opportunity here. Okay, the rice is really boiling now. Is it? I'm always too scared to check. Okay, I think it's boiling. And now the microwave time. Okay, right. So similar opportunity here. If we replace the cos 2x by this, hear these praises from a grateful heart. Each time I think of you, the praises start. Sorry, that was me thinking about whether I am remembering this correctly. I'm just going to double check. So cos 2x is the same or is the same as this, and then we can replace the sign. Of course, you could just check your varying formula sheet. But honestly, I derive benefit from knowing these things off by heart. I mean, clearly I don't know them off by heart, but like, you know, having a sense of them in my back pocket, because it helps you spot opportunities, like, you know, what to replace this with, whether to replace it or not, etc. So I highly encourage, if you don't know it off by heart, at least like being able to derive it, but try to know it off by heart. Know these formulas, as much of your formula sheet as you can, I would say. Anyway, so now I have just confirmed that yes, I am remembering the identity correctly. Okay, right, and that becomes just 2 cos squared x. So now if we put it all together, and it's the best of both worlds, you get the best of both worlds. Shimmy, 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 you get the best of both worlds. Mix it all together, and you know that it's the best of both worlds. Right, it is looking so good for us, man, because now there's a common cos squared x. 2 goes in itself once, and it goes in here twice. So all in all, this simplifies to 2 sine x. And of course, the absolutely beautiful thing about identities is that we can just like, you know, choose an x and see if it works. Of course, we want to stay away from x's that would make this denominator 0, because then the fraction will be undefined. So what is that actually? So we don't want cos 2x to be -1, and we know that let's just see the cos graph, how does it behave? So it is -1. So in this case, it would be -1 when 2x is equal to, so this is 0, 90, 180. So in other words, we don't want x to be 90 or any, so I mean this changes the periodicity of the graph. The period will no longer be 360, it will be 180. So 90 plus 180 plus another 180 or minus 180 and so on. We don't want any of those values anyway, so we will avoid them. So let's choose, what shall we choose? Let's choose 10. So sine of 3 times 10 plus sine of 10. Did I just say minus? Okay, and then here we have cos of 2 times 10 plus, jeez man. Right, so that is the result now. And then if we do the same thing, so if we do 2 sine 10, we do indeed get the same number that is promising. Okay, so let's try another x. Let's try something negative and weird, like negative 502,6 plus sine negative 502,6. I didn't put it over a fraction. Let's see if I can do that now. Actually, I can't do it. Okay, so then we have cos times negative 502.6. Right, so that's what it is. Okay, then we take the same x and we put it on the right hand side. 2 sine negative 502.6, and we get the same number. Okay, enough singing. Wow, I need like a cap of how often to sing in a video. Yo, guys. Right, so this is looking good. I am so confident as I approach the memo. Come on, memo, show me what you got. Did I close the memo? Yo, guys, and then I've also got the elections dashboard just open. Okay, I'm gonna stress myself out. Just find the memo, man. Find the memo. Why would I close it? The mysteries of this world abound. 5.4, the answer is indeed 2 sine x. Let's see if there are some interesting approaches up in here. All you gotta do is ignite. So, interesting approach is so they rewrote sine 3x the way that we did, but then they also wrote sine x as sine of 2x minus x. So yeah, you can definitely try that out and see where that takes you. And then the bottom they pretty much did the same. The denominator they did the same. Anyway, this has definitely picked up my spirit. But of course, we know that the more the questions become, the further we get in the paper, you know, the hotter things become. So let's see if my spirits can stay high for the next 3 questions, which I hope you will check out as well. So yeah, bye.